Hello, everyone. Welcome back to the second installment of this series about analysing time series data. Now, I think at this point we need to add a model, a mathematical equation that does a good job of matching these observations. And there seems to be a lovely smooth curve increasing in steepness as we move to the right. And that to me suggests a quadratic model would be a good choice. Now, by clicking on the chart itself, I get this addition sign. So I'll click on that and I have a trend line down here. I'm not clicking, I'm just hovering, and I will use the arrow to get more options. So always go to more options, and we get a great deal more control here. Now, at the moment, this is the appearances, the thing that looks like a bucket, and it is a straight line model by default, which is a very bad match. So I'm going to go across to this one here that looks like a chart. And this gives me the choice to just expand that a little bit. This gives me the choice to select a polynomial model. Polynomial is a quadratic if we have a degree 2, the highest power of 2. I don't think we need to go higher than that. Now, it's also important, I think, to display the equation on the chart. There it is. We can see there's a number times x squared minus a number times x plus another number. So that's your classic standard form quadratic equation. It uses the x and the y as we typically do in maths instead of t for time and concentration for the y-axis. But I've labelled the x's and the y's over here so we can easily see which one's which. And I'd also like to display the r squared value. The r squared value is known, or it has a name, it's the coefficient of determination. Now, 0.9995 is a very high coefficient of determination. The maximum is 1. So this is very, very close to perfect. It tells me that this quadratic equation is a very close match to the observations. Not perfect, as we would see if we zoomed in. Well, I wonder if I can zoom in effectively to do this. So it's a bit hard to tell. The X's are blue and the trend line is these blue dots. So that is a bit hard to see. I think we need to do some formatting to make that a little bit easier to see. Now it's going to be particularly difficult to click on those dots in amongst the X's. So this time I'll use the format menu at the top of the screen. I come across here to select all the different items from the chart. I should say it was important that I had selected the chart before I opened the format menu. Now I want to click the Series 1 trend line, and that's selected it for me. And now I'm going to format that selection. So if I go back to the Appearance tab, the thing that looks like a bucket, I'll make it into a solid line instead of the dots. And I'll change its color to, say, orange to make it contrast. It's still rather thin, so I'll increase the width of the line a bit, and you can start to see it appearing there now. Oh, it's still dots. Let me see why it's still dots. It's probably because, why is it still dots? That's a good question. Perhaps it's because this is selected as dots instead of a solid line. Now we can see it, and it's clearly too thick. I'll reduce the thickness from 4 back down a little bit. So I want to see the trend line. That's pretty good at 1.5 width, and I can see the data X's as well. Now, if we zoomed back in now, we would be able to see pretty clearly that some of these X's are too high and some of them are a little bit on the low side. But generally speaking, it's following very closely. And that's pretty much what the R squared value of 0.9995 is telling us. Now, while I still have that selected, you can see the little highlight dot at either end of the orange curve. I'll go back to Format. And down here, I have the chance to forecast or extrapolate. So at the moment, that ends at 2025. If I extrapolate forward by 75 years, then the graph is going to go from there all the way out to the year 2100. I could, I could extend this and make predictions in the future about what the CO2 level might be like. Now, you can see that my y-axis has become quite crowded, so I will format the y-axis like I did before. I won't go up in 20s anymore. This time I might go up in steps of 100, and I won't have a minor unit of 5. I might have minor units of 20. So that's pretty easy to reformat. And now I can see clearly that from 1960 to 2025, we have observations. We have a model that fits those observations very well, and we're making a big assumption that this trend continues for the next 75 years with no changes. Now, that is a huge assumption. And if it did, we would predict by the year 2100 that the concentration of CO2 in the atmosphere is almost 700 parts per million, which is really rather alarming when you stop to think about that for a moment. Now, that's enough for this installment. We've added our trend line. We've seen how we can format the trend line to be easily visible, and we've made a forward forecast. Thanks for watching.